The first question I missed asked when in an elevator what the periods of a simple mass oscillator and a spring mass oscillator and the pendulum would be affected. So to do this, you would just use the equations. And you can see that in spring mass oscillator, gravity isn't involved, and in an elevator, you would feel greater gravity as you move up. So this would result in the time for the pendulum decreasing and the spring staying the same. And then the next question I missed was asking when the units of a spring constant were divided by, when the units of mass were divided by a spring constant, what the remaining units would be. So to solve this, you would do mass is going to be equal to kg, and then k is going to equal, or the spring constant is going to be equal to n over m, and force is going to be equal to ma, so kg times meters over second squared. So you're going to divide these, and you would get kg over kg times meters per second squared. And then, this is all over meters. So these two would cancel out, and then these two would cancel out. And then that would just leave you with 1 over second squared, which would just be second squared. And then out of the answer choices, the only one that makes sense for that is period, or time, and time squared. The next question asks, consider a mass attached to a string fixed to a pendulum of period t. What is a new period if the mass is replaced with 5m? So the equation for a pendulum is 2 pi L over g. So mass is not involved, so it should just be t and remain the same. The next question shows a graph. The graph of a spring mass oscillator, and asks to determine the spring constant. So to do this, you could use t equals 2 pi m over k. And then you would square this. You get t squared equals 4 pi squared m over k. And since we know m and t squared from the graph, we can see the period is 1.6, so we can solve for this, and we would get k equals 4 pi squared m over t squared. And when you solve this, you find k is equal to 100 newton meters. The next question I missed was asking how the period of a pendulum would be affected when it was taken to a planet with 25 times the mass and 9 times the radius. So to solve this, what you would have to do is you would have to, first of all, realize that from the equation sheet, you can see gravity is equal to gm over r squared, and you can see that you can just plug this in for the equation of a pendulum, which is t equals 2 pi squared of L over G. And when you plug this in, you get t equals 2 pi r squared G L over GM. So since r is squared, and this would be 81 over 25 the squared of that, which is 9 over 5 when you solve that. So the next part of this, the next thing I got wrong was you had a oscillator like this, and it asks why it undergoes oscillatory motion. And I initially guessed because I didn't really understand it, but the correct answer is that net force is always exerted on the marble to the bottom of the bowl, and that basically means that it's always having a force towards equilibrium, as that's its equilibrium position. If you think about it like that. And then the next question I missed had two objects, which were x equals 0.1 cosine 12 pi t x. And then I just basically had another object too, which was x equals 0.2 cosine 6 pi t. So now what you've got to do to figure this out is you can just use the equation t equals 2 pi over omega. So as omega increases, the period should decrease. So since object 1 has a higher period, that means that since object 1 has a higher omega, that means that it should have half the period. And then object 1 has a higher amplitude, which would be this number, based on what we learned in our notes. So it would have half the amplitude. The next question asks, a simple pendulum has a mass m and is placed with a mass of 4m. So for this, it would be 2 pi L over G, and because that's a pendulum, so the period would remain the same because mass is not affected. Then the next question asks about how the next question asks about how a period could be gotten from this equation in the form of x equals beta sine omega angular velocity times t plus phi. So what you would do for this is it gives you that omega is equal to 4. So all you have to do is you just have to use the equation t equals 2 pi over omega. And when you do this, you get that's just going to be 1/2 pi, which is 1.6 here. The next question I missed asked basically had a graph like this. And asked about the velocity and displacement at this time t0. And so basically, since the acceleration is positive, that means that basically it's over here somewhere. Like if this is its equilibrium position, it would be to the left of it. So the velocity would be going right, and the displacement would currently be negative. And I mixed up displacement and velocity, so I kind of just solved for velocity 2 times initially. Next question I got wrong asked about a torsion pendulum. And it asked basically to find the angular displacement, the angular acceleration when the displacement was half of the max theta. And when this is the case, the force would also be half. So since T equals IA equals force times radius, what you could do is you could just say force is going to be equal to 1/2 F0 D, and then this is that part, and then I is just going to be equal to what it gives you, which is 1/2 MD RD. And then this I would be squared, and that these two would cancel out, and these would cancel out, and that would just leave you with F0 over MD RD. The next question asks, how could you, if you had a rod, how could you have a shorter period for small angle oscillations? And basically, that would mean that you wanted it to be harder to move, so it would have a harder time going farther, and therefore have a faster oscillation time. And to do this, you could just double the pivot to the center distance. And I mixed up which way would decrease or increase the rotational inertia, which would be doubling the pivot to center distance. And then finally, the last question I missed had a graph like this. And it was for the FRQ, and asked basically, gave you a period like this, and then at this time, which is T1, it basically added 3m to the initial 1m, and asked how this would affect the momentum and to sketch it. And what this would do is, first of all, the amplitude would remain the same because momentum is conserved. However, because the equation for a oscillator is this, since this would be 4m now, that would mean that you would double the period, so it would look something like this. And yeah, those are my test corrections. Thank you.